Welcome to this playlist about two major implementations of the list and collection interfaces in the Java Collections framework, ArrayList and linked lists. These videos are meant to help you gain a good understanding about how these classes behave under the hood. Java Collections Framework, what is it? It's a framework that contains dozens of interfaces and classes destined to help developers handle data more efficiently than just having to work with arrays. Roughly, it can be broken down in three parts. The first part, unordered collections or sets. A set doesn't allow any duplicates, so each element is stored only one in a set. Second, dictionaries and maps. They use key-value pairs. They store references to objects with a lookup key, which can then be used to access the object's value. And then the third part, what this playlist is about, ordered lists. These allow you to insert items in a certain order and retrieve them in the same order. Displayed here in this UML class diagram are the main interfaces and classes related to ordered lists. Interfaces in blue and actual implementations or non-abstract classes have a light gray background. Note, this representation is not complete. Only the methods that I come across in my videos are listed here. If an interface doesn't display any methods, like with this iterable interface, it doesn't mean that there aren't any. It's just that I don't discuss them. But know that all the interfaces, of course, contain method definitions in the GDK. Note as well that not only public methods are displayed, like grow or element data in the ArrayList class, or link before and unlink in the linked list. I show them because I'll bump into them during my demos. Let's quickly review this. At the top of the hierarchy is the iterable interface, which allows you to iterate through a list using a for each construct. Below that, extending the iterable interface, is a collection interface, of which I'll discuss the methods size, add, remove, and clear. Extending collection to the left here, we have the list interface, which adds some more method definitions such as add, remove, and get and set methods. These methods allow you to work with a specific element located at a certain position specified by an index. And then below that, two major implementations of the list interface, ArrayList and linked list. Both to the client do basically the same. They allow you to add and remove elements any way you want, to clear a list or access a particular element or change its value. So why then two implementations? Well, because behind the scenes the way they work is completely different. The implementation of some methods in ArrayList have some advantages over those implemented in linked lists, and vice versa. When I say advantages, I say speed. Some methods are much quicker in ArrayList, like get and set, but then other methods like add and remove are quicker in linked lists. And then it depends which ones. Note as well, linked lists implements more interfaces. So again, why two implementations? Well, let's say that the ideal world doesn't exist. You can't have all the advantages in one implementation. You can't have it all. Depending on your priorities, you'll have to make a choice. But before choosing an implementation for your application, it's best not to just pick one, because someone using your app might end up not having optimal response times. Better to make a deliberate choice that can best be made based on knowledge, and this is what these videos help you to do. Gain a more profound knowledge about how ArrayList and linked list behave behind the scenes. Let's look at the description of the main methods that I'll discuss. To start with, how does an ArrayList and linked list behave when adding elements at the back? Two widely used methods that I'll cover are first, a single parameter add method, which appends a specified element to the end of a list, and then the add all method, which appends elements of the specified collection to the end of a list. Then another add method, which inserts the specified element at the specified index or position in a list, a remove method, which removes the element at the specified position, and a clear method which removes all the elements from a list. Then I'll discuss the behavior of the get method, which returns an element at a specified position, and the set method, which replaces an element at a specified position. Preliminary notes. Now, in order to explain the behaviors of ArrayList and linked list in my animations, I constantly apply fundamental programming concepts, such as variable declarations, method invocations, the use of primitive and reference types, stack frame, local variables array. And I do this by looking behind the scenes in 3 memory areas managed by the Java virtual machine. Basically by demonstrating the interaction that the execution of a Java statement in the method area has on data in memory, mainly data that is located on the stack and the heap. If you're not familiar with my animations in which I explain all these concepts, I advise you to first watch the necessary videos in my playlist called Stack and Heap Memory Fundamentals. Do that before starting here, because I don't start from scratch in this playlist. If you search for Java Under the Hood in YouTube, there's a good chance that you'll bump into one of my videos. I will also regularly refer to that playlist, of which the link can be found in the description page below. Just a minor change regarding the notation of values of references, addresses of objects. In the Stack and Heap Memory Fundamentals playlist, I use the decimal notation. In this playlist about list classes, I use the hexadecimal notation. Basically, it comes down to the same thing. An address is just a number. But I do this in order to make a clear distinction between a value representing an address and a value indicating an ordinary number, such as that of a counter. In this video series, I also assume you already have some experience with ArrayList and linked lists. If you don't, I think it would be useful to first gain some knowledge about these subjects. I conclude this series by comparing array to linked lists and come up with some best practices and a final conclusion. Okay, I hope you find this playlist educational and will get a lot out of it. Enjoy the videos.